Geotrig lesson 7. We'll call this day 1. Today we're going to talk about inductive and deductive reasoning and coming up with an argument that's going to be valid or invalid. There are a few definitions on the next 2 slides here that we need to know, so if you have them printed off, it makes it a heck of a lot easier today. And if you don't, you got some copying to do if you want them all. So, the first definition that we should talk about is inductive reasoning. I took the liberty, guys, of putting the definitions already on here so that we don't have to come up with them and spend a lot of time talking about what it is versus how or why we are going to use it. So inductive reasoning is the process of trying to find a rule. We actually do this a lot, or maybe not we as a group, but individually, there have been many times in here where we do a problem and your first instinct is to say, wait a minute, is there a connection between the way it's set up and the answer we just got? Is there a possibility of finding a shortcut? Sometimes, yes, there are some shortcuts that we can say work, awesome, right? Mm-hmm. That would be an inductive type of process. You look at what has been done to find a rule that works. Make sense? We have this thing called induce. It's to formulate. Okay? It's to come up with some kind of rule. And then we have deductive reasoning. Deductive reasoning is the process of using established rules that have been formed to find something new. Using your properties and definitions. What you do to one side, you do to the other. So additive inverse properties or multiplicative inverses properties. All of those things are rules that allowed us to go step by step, deductively reasoning why something's true or not. If I add 3 to both sides as a step, I don't change the value, which then leads us to do something else. So you're using rules to formulate something or to get it, versus inducting is you're trying to find that rule. Now this is where things get a little interesting, I'm going to say. Because we're going to get away from numbers and letters, and we're going to go into more of the argument side, more of, I guess, philosophy in a way. And it does take a little bit of reading it a couple times to understand it. Sometimes it takes one person to say it with an emphasis on a word or two that could somehow change how you think about an argument, being true or not true or valid or invalid, and we'll get to that in a second. So, there are some things that we have to have here understanding. If a rule is false, false, yeah, false, and you use it properly, as in you use it with the notion that it was wrong in the start, then the conclusion reached can be false. It's kind of like someone saying, now we had kind of a, I wouldn't say it's an argument, we had to talk about this part with 6 hour. And think of your Pythagorean Theorem, right? It's a squared plus b squared equals c squared. As in, the sum of the legs squared equals the hypotenuse squared.
Correct.
Well, what happens if you were to solve for one of the hypotenuse, but you accidentally put the hypotenuse as one of the legs? You're using it falsely, right? But you could still say, oh, I can square this plus this squared should equal that squared. So you would use it correctly, but even though you have it in the wrong place, that means the answer can be, or probably will be, wrong. So you can use something that's wrong, which means you probably get a wrong answer. But sorry, use something wrong in the wrong way, but properly or the right way. See, that's what the problem is, right? It's like
That's the problem. Yeah.
it's kind of feel like I'm running in circles here. Because as soon as it kind of sounds like it's right, it doesn't sound right.
I get what you're saying.
You guys picking up what I'm putting down?
I'm picking up what you're putting down.
It's using something wrong but the right way.
Okay.
Putting the hypotenuse where a leg should be is wrong.
Not really, though. Are you using it the right way, though?
Because you are doing a squared plus b squared equals c squared. You're mixing up your a squareds and b squareds and stuff. Okay. Right. The study of logical reasoning is a study of the proper use of its rules, and the truth or falsity of the rule is not a consideration. This is big, guys. If I said the rule states all pigs fly. No, hold on.
Oh, wait, no, it's like a logic game.
This is, okay? Guys, if I make the statement that all pigs fly, they fly. I'm not saying can they in real life. I'm talking I can construct some world, there it is, where all pigs fly.
I got you.
Pigs, okay?
Can you at least draw wings with this?
Okay. Guys, this is what I'm talking about. Listen. In this world,
So the pig is the circle, and the circle around that is flying.
careful. This is what I would consider as a diagram. Watch this. The rectangle. The rectangle is this world that we're talking about. And in this world, there are things in this red circle that fly. All things that fly. Birds, bees, okay? All those things. But if I state all pigs can fly. All pigs.
Like in this hypothetical world.
In this hypothetical world. I can then draw a circle with pigs being, all pigs are in that circle. And all of that circle would be within flying. This flying circle.
I get what you're.
Okay? Ladies and gentlemen, listen to this. This is what's going to help you. Because it does get complicated. Every one of these, we'll call logic puzzles, represents a brand new world in that particular construct. Okay? Okay. I'm going to turn the slide. More definitions. Start putting some of this together. Syllogism. I think that's the right way to say that. This is the formal process in which a conclusion is reached by two statements that we are going to call premises. Those two premises, guys, are these first two, or second and third lines. The second and third line, we got a major premise and a minor premise. The major premise, yes, is a universal affirmation. The universal affirmation is your major premise, and it basically states that a group has equality. All pigs can fly. All hockey players can skate.
Yes.
All chairs have 4 legs.
Not
No, this world.
In this universe, they just talk.
I'm not talking about any different things. The minor premise, the second statement, should state that somebody is in that group. Well, if you're in that group, then you have to possess that property or quality. So that's the minor premise says, hey, Frank is a pig. Therefore, Frank can fly. That's the conclusion.
I got you.
The conclusion, guys, follows that if a person is a member of the group, then that person will have the quality of the group.
Like even numbers are divisible by 2. So if you're 8, you're divisible by 2 because
If you're 8, or 8 is even, therefore 8 is divisible by 2.
right, that's what I said.
Yeah. Okay. Ladies and gentlemen, so this thing right here is your syllogism, that puzzle. Premise 1, major. Premise 2, minor. 3, conclusion. Those 3 statements are either going to form a valid argument or an invalid argument based off of the 2 premises and conclusion. For it to be a valid argument is if the conclusion is a logical consequence of a member being part of the group that has the quality, then they have that property that's valid. It's an invalid argument if the member has the quality or not and is not even part of the group. Hence, I did drop the fact that I said all hockey players can skate. Josh is a hockey player. Therefore, what? Guys, 3 dots means therefore. Therefore, Josh can skate. That would be considered a valid argument.
Correct.
Because Josh is a hockey player, a member of the group that can skate.
Okay.
Yeah, everybody have that written down?
Yeah.
Okay. Okay. I copied and pasted here and I erased half. So I want to restart this. What if I still state, I'm over here, all hockey players can skate again. Okay? Same major premise. Universal affirmative. Or affirmation there, affirmatives. All hockey players can skate. Now, Josh can skate. Therefore,
Hockey player.
is Josh a hockey player? I'm running out of room. Is he a hockey player?
Yes. No. Maybe not. Yes.
Maybe not. Does it put Josh into the group? But he has the characteristics, so he must be a hockey player, right? No. Heck, he could be a figure skater.
Yeah, Josh.
He could be a basketball player that just happens to know how to skate.
He's not telling me.
He gets put on skates on the basketball court.
What I'm saying. Guys, this, okay, first one was a valid argument. The second one is invalid. The second one's invalid because it does not place Josh into the group. Therefore, you cannot stay with certain that he is a hockey player. He doesn't have a quality. Just because you have a quality doesn't make you a person on the team. Now, I'm going to squeeze it into this area here. Look at this. Here's that world. Here are people who can skate. Of the people who can skate, there is a subset of people that play hockey. That means that there is a little wiggle room there for Josh to be here, can skate, but not be on the hockey team.
Maybe he's just not good enough.
Okay? You guys kind of see how that's an invalid argument. If you're not part of the group, you can't just say, because I have the quality, I'm part of the group. Doesn't work. A table has four legs, right? Doesn't make it a chair. Remember, go back to the one. All chairs have 4 legs.
Right.
So a table has 4 legs. Therefore, it's a chair, right? No. Okay? But it wouldn't be a chair. So that's what we have to do with. So, I want you guys, on the next slide, identify valid or invalid arguments. Here we go. So, notice up here, I have major premise, minor premise, conclusion. Number 1, all men are mortal. Mr. Konchak is a man. Therefore, Mr. Konchak is mortal. Valid or invalid?
Invalid.
Valid.
It's valid.
I mean, can we just
Valid.
prove the fact that he's...
Does it?
It's valid. But it's also invalid because he's
Does it give us a group that has a characteristic?
Yes.
So if you're a man, or a men, right? All men, men, then you are mortal.
Yep.
So if a man, then a mortal. Mr. Konchak is a man. Therefore, Mr. Konchak is mortal. Puts him in the group. He has the characteristic. This is valid. It's valid.
It's sandwich, Mark.
Number 2. Hey, this one seems more mathy because it's the sum of the exterior angles of a convex polygon is 360 degrees. Triangle ABC is a convex polygon. Therefore, the sum of the exterior angles in a triangle ABC is 360 degrees. Valid or invalid? It's kind of tricky. What's this first statement saying? If you're this, then you have this.
The other convex. That's
You're a convex polygon.
Yeah? Angel?
That you have 360 degrees angle.
Okay. The first statement is kind of backwards in a way, isn't it? You're saying that if convex, then exterior is 360 degrees. Can you see that? The sum of exterior angles of a convex polygon is 360 degrees. So it's stating that if you're a convex polygon, the sum of the exteriors is 360.
Yes, so it's a valid statement.
Triangle ABC is a convex. It puts it in the group. Therefore, it has to have the
Some.
quality. So that is a valid argument. Now I can see some of us right now trying to figure out, okay, how can I have 360 degrees on a triangle? What if I call this a equilateral triangle, guys? Can you guys agree that I could extend these lines out? And that this is a 60 because of definition of vertical angles. What's the leftover angle is in there? It's 120. If I'm taking a walk, okay, and I get to this vertex, I'm technically looking down this line right here, right? What would it take for me to go this way? How many degrees? 120. I get all the way over to here. How far? We're here. It's going to take me looking straight ahead. It's going to take me 120 to look again. 120 again. And 120 plus 120 plus 120? Or three of them. So 120 plus 120 plus 120 is 360.
What about the 60s?
Doesn't matter inside. It's outside. Basically, I made a full circle walking around that object. 360 degrees. Couple minutes left here, guys. All frogs are green. Henry is a frog. Therefore, Henry is green.
That is valid.
2 is valid, right?
Yes, 2 is also valid.
Well, you didn't draw the line, but it's still valid.
Valid, valid. Okay, save some time. I'm going to move on.
This one is
If it rains, I will go to town. It did not rain, therefore I did not go to town.
Valid.
This is invalid.
What?
Wait a minute.
Wait, oh, because it's raining? If it rains, I'll go
It, guys, if it rains, I have to go to town. It didn't rain. Does it say what I have to do?
No, you don't
No.
have to.
I could technically go to town, not go to town. I could sit at home and look out the window.
That's right.
Okay?
It's not sad.
It did not put it into the first group that said it did it. So therefore, it's an invalid argument. A car will not run without gas.
Valid statement.
I don't have any gas in my car. A car will not run.
Invalid.
This one
You can always
is one
push
of those weird ones again. What is the first statement really saying?
it. Car cannot run without.
So it's not run. Is it saying that? No. It's saying
No gas.
no gas, no
Running.
run. My car does not run. I must be out of gas. Oh, wait, sorry. Well, I read 6.
Yeah, yeah.
I don't have any gas. My car will not run. That is
Valid.
valid.
Invalid.
The next one puts me in the fact that my car's not running. Same same premise. Well, it could be other things, couldn't it?
Yeah.
Maybe your
Keys.
battery's dead. Maybe your you didn't have your keys. So therefore, this is invalid.
No car.
Okay? Guys, we're going to finish up. We're going to finish up. I got a couple more slides here of trying to use the same logic, but what happens if we say the opposite of something? Going back to the it didn't rain. Well, maybe there's something I can say about not going to town, not raining, things like this. So we're going to learn how to be able to handle some more problems by changing it around maybe a little bit more. No homework tonight. Tomorrow we will have homework. Have a great day.